Starting with today, we are learning Unit 1, Introduction and Scientific Skills, Physics in Everyday Life. Peter Griffin. All right, so physics in everyday life, huh? Why do pancakes always land butter side down? Is gravity picking favorites? Peter Griffin. But think about it. When a pancake leaves your spatula, it often has a little spin in height. Could the pancake's rotation and the time it takes to hit the floor combine so that the buttered side faces down? What does that say about how small differences in angle and speed change outcomes in everyday moments? Peter Griffin. So tiny changes can make big differences. Kind of like when I decide to get a haircut and suddenly everyone thinks I joined a cult. Okay, what about the car? Why does it feel like the brakes sometimes grab and sometimes don't? Is the road secretly conspiring? Peter Griffin. Not a conspiracy, Peter. Think about friction, surface conditions, and reaction time. How do different surfaces, wet, icy, or just greasy, change the force needed to stop? If you were designing a safety feature, what measurable variables would you control to make stopping distances predictable? Peter Griffin. Predictable stopping distances, so like measuring speed and surface friction, and maybe telling folks to not text while driving. What about the toaster? Why does the bread brown? Is it magic or tiny sun rays trapped in my kitchen? Peter Griffin. It's energy transfer. Electrical energy becomes heat, and heat causes chemical changes in the bread surface. Maillard reactions. But here's a question. How might changing the power input change the rate of browning? And what trade-offs are there between speed and evenness? If you were designing a toaster for Quahog, what would you optimize? Peter Griffin. Evenness, definitely evenness. I don't want one side burnt and the other still doughy. Last one. Why do I feel heavier after Thanksgiving dinner? Is my mass secretly multiplying? Peter Griffin. Your mass does increase when you eat. It's matter you've added. But the more interesting question is how our bodies convert chemical energy and how conservation laws apply to everyday life. If matter is conserved, where does the energy go when you burn calories? How does that apply to designing healthier lifestyles or better engines? Peter Griffin. Wow, thinking about physics makes me hungry and smart at the same time. Maybe tomorrow we can test pancake flips, braking distances, and toasters. Or maybe just go for pie.